Everybody, hope you enjoyed the little interlude that we had. I'm going to have a conversation now with I want to say a very interesting young man, a very interesting man, Dr. John Abeles. Thank you for coming in.
Thank you for having me.
My pleasure. You know, we were talking a little bit, and I know you were talking out in the front office a little bit, and I'm intrigued. I'm one of those people who I've taken technology and made a career with it.
Yeah.
I'm not a techie, but I'm very aware of the speed that technology is advancing and the uses. But I'm also daily, I'm amazed at some of the uses that I'm hearing about that are now in work or have become available because of the technology we have nowadays.
Yeah.
Right? You're involved with quite a few, I don't know if organizations is the right word, corporations are the right word, institutions.
Yeah.
But we were talking about you doing something with Stanford.
I'm doing several companies. One
Yeah.
One is with Stanford University. The technology emanates from Stanford.
Yeah.
Okay, let me step back a bit.
Okay.
And just give you a background so you
Yes.
can get the context of what
Okay.
I'm doing now. Okay, so I'm a physician, and
Yes.
I also have a degree in pharmacology.
Right.
And armed with these trainings, I not only practiced medicine first in England, but then I also joined a pharmaceutical company as a medical executive.
Yeah.
And helped to develop new drugs, helped to market drugs, helped to train reps, etc., deal with the regulators, develop new medicines.
Yeah.
I was brought over to the United States in '73 with Pfizer from the drug company in England, which was called Sterling. And then from there, I went to another drug company. And then finally, I landed up as the first full-time MD analyst on Wall Street. So I sat at the offices of Kidder Peabody, a venerable old, very well-respected investment bank. And I was an authority to the investing community.
You were the man.
I was one of the men to whom they referred to educate them about what was happening at various companies in the pipeline of drug development.
Yeah.
I better switch off my cell phone.
Okay.
And from there, small companies started to come to me, and Kidder didn't want to deal with small companies. I did, because they all were very interesting in terms of cutting edge science. And so I left Kidder. They kept me off council, and I became my own family office and consulting firm, developing emerging medical companies. And these ranged, and since this has been going on now since 1980, I moved from New York to California to take that up. I lived in California for 10 years. And then I moved to Florida in '93.
Couldn't get away from palm trees, right?
Well, I'd like the East Coast.
Yeah.
It was closer to Europe, where I was doing a lot of work. It was closer to New York. I was doing a lot of work. And frankly, Florida was an attractive place to live.
Yeah.
And I thought I'd be in the vanguard of venture capital development in Florida. It hasn't worked out that way so much, but I still maintain my Florida office.
Yeah.
I have an office in New York City, and I have another retreat office in rural Connecticut. So I continue now to develop new companies. I name them very often. I found them sometimes. I always get involved with my own money, in my family office money. I find other people's money. I recruit management. I recruit directors on the board. I help to strategize the research. I help to network with pharma companies, major pharma companies as strategic partners. I deal with offerings and help to promulgate and develop these companies. And several of them have been acquired with gains, and others have gone public and have gone fairly well in the public arena. And net, my family office has benefited substantially from these activities. And I always, am developing new companies, keeping myself young. I'm now
All right.
almost 75.
All right, good for you. And I'm glad you brought us up to date with that resume, because everything I had, it would have taken the 20 minutes to go through everything that you've done and what you're doing.
I have a very talented family. All my kids are performers in New York and all working. They're on Broadway,
All right.
2 of them, and others on television and indie movies and off Broadway. And
we'll talk off air. I do a lot with film and theater.
I'm very happy with my family, actually.
Right, great. All right, let's. Everybody's kind of got an overview of what you do and who you're working with.
Mm-hmm.
I came into the conversation earlier about we were talking about cancer and tumors, and that medication can treat it if it can find it.
Right. I think the best thing we can do in our time left to us is perhaps for me to put forward examples of what I'm doing, including that one you mentioned, and explain the technology in layman's language.
Perfect.
So that people get a flavor of what I'm doing. Founding companies, financing, pushing them forward. Okay, in the case of the one that you just mentioned, Bryologics, I named it. I name companies all the time. Actually, there's a funny story I have about that.
That's a creative gene that you have,
well,
right?
Products and companies are, I used to help the marketing departments of pharma companies quite a lot, coming up with drug names and company names.
So you came up with the names that we can't pronounce or spell.
So, well, Bryologics,
that's easy.
The story is, I was in the beginning of the biotech era in the 80s. In the beginning of the 80s, I was in Milan, at a biotech conference, right in the beginning of the biotech foment. Genetic engineering. And an Italian entrepreneur came to me and he approached me and he says, "Dr. Abeles, would you like to look at my company?" And I said, "Of course, doctor. I mean, do you have a business plan?" He handed it to me and I went back to my room. The next morning I came back and I said, "Dr. Roberto, I would like to get involved with your company, but you really do have to change the name." And he says, "But what is wrong with Gen Italia?"
Okay.
Actually, it's a story I like to tell. But no, I do name the companies. Bryologics is named after a bryosome, which is an organism that grows in the ocean, and it produces this very rare molecule called bryostatin. And bryostatin costs $1.5 million a gram to get out of those polyps that grow on seaweed. And the NIH and the National Cancer Institute was working with this molecule as a chemotherapy at high dose to kill cancer cells. But it's now been found that this, at very low dose, does something different. When you give it in small doses, it tickles the cancer cells so that it makes them put out more flags, identifying them. It's what's
so it takes them out of hiding.
It takes them out of hiding because what they do is they start to express what's called antigens, which are markers for the cell.
Right.
And it's only if the cell produces such markers that the immune system can see it. And many cancers hide their markers or don't have enough of them. So our drug is now being investigated at very small dose to do that job. That would be accompanying the use of all these fantastic new immunotherapies that are out there, things that are jazzing up the immune system to attack tumors. But if you jazz up the immune system and the tumor is not visible, all you've got is a jazzed up immune system and you won't get an effect. So our drug is an accompaniment to all these new immunotherapies that are working on the immune side. Ours is working on the cancer target.
So if this actually works,
yes, it's worked in animals. Okay, so and now the NCI is starting to use it in this fashion with us, cooperating with them, to start with using it in a type of lymphoma that affects kids, B-cell lymphoma, and their clinical studies are about to start.
So will that potentially get away from the chemotherapy treatment?
It'll get away from that drug being used as a high-dose chemotherapy. It'll be used as a low-dose immunogenicity agent. Immunogenicity being the promotion of immune recognition. Now, the one other factor why we're working with Stanford is that this molecule is being present, being extracted from polyps, and very, very expensive. It's used as a reagent in certain research labs, and it's very expensive per, as I said, $1.5 million a gram. Stanford, a professor there, a very famous professor, Paul Wender, came up with a synthesis for this. Now we can make it chemically.
I was going to ask.
And so now the price has come way down, and it makes it feasible now.
Right.
The NCI spent $400 million on this molecule in clinical studies at very high dose. We inherit all those data. So now we have all kinds of information about how it behaves in humans at high dose. So the FDA is very ready to say, okay, go ahead and use it in low dose. So we get a jump on the development,
right.
on the development.
It's incredible.
Stages of this company.
It's incredible to think it costs so much just to get a gram of something.
Now ours are several orders of magnitude cheaper.
Yeah.
So we're back in the drug business with this thing, because we use very low dose and we have a synthesis.
Right.
So the big price points are disappearing.
And notoriously you hear about a drug, and the first 10 seconds of the commercial is what the drug does.
Yeah.
And the next 50 seconds are may cause internal bleeding, may cause suicide.
Yes. Well, we know the side effects of bryostatin already because of those high doses, and even at those high doses, it was relatively mild. The major side effect at that high dose was muscle pain, but at low dose, we anticipate very little in terms of. So we're not a directly cancer-killing drug. We're an accompaniment to other cancer-killing modalities that deploy the immune system, because we make the cells more immune recognizable.
Right. Yeah.
Now, another company, which I named, is called in the cancer arena, which I'm developing now. All of these companies are developing now, and that's why I'm bringing them forward just as examples. The one from New York is called Oncolize. I named that. Onco means cancer, and Lyze means bursting, or killing. So Oncolize is developing a small protein. It's called a peptide, and we can make it very cheaply.
Right.
And this peptide gloms onto almost every type of cancer cell, with very few exceptions, onto a special receptor which we've shown, and only it gloms onto cancer cells. It hardly touches normal cells. Mm-hmm. It doesn't touch them, or hardly touches them. So when that happens, everything is focused on the tumor. It's site directed to the tumor.
Right.
It gloms onto that, and now it doesn't interfere with the metabolism of the cell. What it does is pokes a hole in the membrane of the cell. And you say, well, what does that mean? Well, when you poke tiny holes in the cell of a membrane, you cause an osmotic ingress of fluid from the extracellular environment, the extracellular fluid, and the cells start to suck in this water, and they get bigger and bigger, and they burst. That's the lysis. So we are causing very quick cancer deaths by lysing the cancer cell specifically.
So you're blasting it away.
Yeah, and in animals, we have found no side effects. And now we're preparing to go into humans. We have done work. There was a paper's coming out now that will show tremendous activity in special animal models where we take normal human leukemia, the worst leukemia called acute myeloid leukemia, and we give it to animals that can sustain this leukemia. They get human leukemia because they're able to receive it, and they get sick and die within weeks and months. And our drug not only decreases the leukemia cells in their blood, but it also attacks what's called the leukemic stem cells, and that's where the leukemia originates.
Right.
So we're hopeful that we can induce in humans very long remissions of a very, very dangerous disease. It's dire. Or maybe if you use enough and for periods that we'll have to investigate, maybe we can even come with what's called a cure.
Right.
I hate to use the word cure in anything
Yeah,
to
I
do
understand.
with cancer.
So when it blasts the cell,
Yes.
the cancer, the
Mhm.
leukemia, does the body evacuate it through normal system?
Yes,
And
there
it's
are
an
there
endocrine
there
system,
the macrophages will glom onto all of the
Yeah.
stuff. It'll be excreted in there will be enzymes that will chop up the proteins
Right.
of the cancer. Once a cancer cell is burst, it's no more a cancer cell. It's not dangerous.
Right.
It has to
It's
be
great.
it has to be intact to be
Right.
dangerous. The contents of the cancer cell are not dangerous, except if we release too much at one time. It's a
Yeah.
nice problem to have, because
Yeah.
a lot of therapies, if you attack a tumor too aggressively, you get what is called tumor lysis syndrome. That is, too much gunge gets into the blood and gets glommed into the
Yeah.
kidneys, and you start getting problems.
Yeah.
There are ways of avoiding this, and when we use our product at Oncolize, it's called OM301 right now. We anticipate that
I'm sure you'll give it another name.
yeah, but we will prepare. It's a nice problem to have too much activity.
Yeah.
That's that's a side effect from too much activity, not a lack of activity.
Right.
So that's a.
You're involved in so much, and there's so much to talk about. And unfortunately,
There's a third one
yeah.
I want to talk
Okay.
about. So I just paint a big picture. Company called Serpin right now, but I've renamed it. I didn't name Serpin. I don't like the name Serpin. Serpin. Particularly, it's not a bad name, but mine is better when we're renaming it Immunition.
Yes.
Okay. So now Immunition is another company that is developing a very short protein, a peptide, and this peptide comes from a giant molecule that's in your blood. It's called alpha antitrypsin.
Yes.
And it has many, many functions. Now, there are companies selling alpha antitrypsin to the market. It's a $2 billion drug. Baxter is a big one. Grifols in Spain and Kamada in Israel are the main factors in the marketplace. And they sell this mostly for deficiency of alpha antitrypsin, AAT, or using it for cystic fibrosis. That's its main use. We have found a little piece of it such that if your computer laptop here is our molecule,
Yeah.
then the parent molecule is about the size of this room.
Okay.
So we are making
really,
it for pennies.
a piece of sand, basically.
We are making it for pennies.
Yeah.
And it costs dollars and dollars and dollars to get it out of the blood. So we make, and that piece that we found is the anti-inflammatory part of this molecule. Our molecule is 350 times more potent than the blood molecule that's on the
Really?
market. And we are now positioning it in all kinds of inflammation and autoimmune disease. Now, you know these ads, Humira, Enbrel, Rituxan, Xeljanz.
Right.
There are numerous
I
ones.
even know some of the actors that do the commercials.
Okay, and they're for psoriasis and for rheumatoid arthritis and
Right.
for lupus and all these, and they're wonderful drugs. They do a job, don't get me wrong, but they're dangerous
Yes.
because they suppress a huge part of the immune system. They kind of whack the immune system
Right.
in toto or in part.
Right.
Now, when you do that, you suppress the bad immune effects, the bad antibodies that are attacking you, or the bad cells that are attacking your own
But
tissue.
you're killing off good stuff.
But you're killing off the good stuff
Yeah.
as well. And that's why you're in danger of getting more cancers and more serious infections. And people warn about brain infections, about TB,
Internal bleeding.
about lymphoma, all kinds of things. Ours has none of that. Our animals have no reactions, toxic whatsoever. And we've done the first phase 1 in humans. Again, no side effects. So we're now beginning to position.
And this is an anti-inflammatory.
Serpin, it's an anti-inflammatory immunomodulator that's derived from alpha antitrypsin, and it sits on a receptor that naturally modulates the immune system.
Okay, so I know what you said. You know what it's used for and all that. Once this makes it to the market, so to speak, will it, as an anti-inflammatory, will it take the place of the person who takes like Advil for people? I know people will take like Advil because it's got an anti-inflammatory in it.
Yes, there's a place for every therapy. We're not going to displace Advil, of course.
Right.
But for mild inflammations, it's
Right.
perfectly good to take Advil.
So it could be prescription or over the counter
Oh,
at
that's
some point in time.
Yeah, or there are a lot of these non-steroidal anti-inflammatories, but they come along with side effects too,
Yeah.
mostly bleeding.
Right.
Either gastrointestinal bleeding or worse, internal bleeding, especially in the brain.
Yeah.
So you have to be careful taking non-steroidals long term,
Right.
and they also have sometimes have cardiac effects.
Yeah.
But then when you graduate upwards, you go to things like the steroids, like cortisone and hydrocortisone,
Yeah.
prednisone,
Yeah.
and sometimes they use anti-cancer drugs like azathioprine or methotrexate, and those have a massive effect on the immune system, and they're very dangerous too. Steroids have a metabolic effect. They cause all kinds of diabetes and cataracts and muscle wasting, all kinds of problems with massive doses of prednisone. Then when you get to the Humiras and the Enbrels and those kinds of drugs, Retux, you are really squashing the immune system.
Yeah.
And
You're changing,
so we're coming
one problem
in as
for
a
another.
safe anti-inflammatory.
Yeah.
Now, we anticipate with Serpin, now going to be called Immunition, that you will use a subcutaneous injection like a insulin needle and syringe, just that same sort of thing, once a week.
Oh, wow.
Now, people with diabetes are using insulin injections
Daily.
3 times a day, perhaps, or at least once a day.
Right.
But so once a week ought to be perfectly okay for someone who's got a bad immune disease like lupus or arthritis or psoriasis, etc. They wouldn't mind that at all.
Okay. I'm hoping at some point in the near future we could have you back, because there's so much more to talk here, and of course we've got time restraints. But before we go on, I want you to give out, if anybody did want to speak to you or get involved
with these companies.
Yes.
Well, these companies are all biopharma companies have capital raising stages.
Right.
And if people are interested in participating, first of all, they have to be accredited investors,
right,
or qualified investors,
right,
even more,
exactly,
or institutional investors. And if they're interested, what I would do, I wouldn't sell them on anything. I'm not a broker dealer, but I am a member of these companies, and so what I would do is to put them in touch with the top managements. And they can take it from there. Okay. So if they want to reach me, they can reach me through my email.
Yes.
And my email is DR for doctor, then J for John, and then my family name, Abeles, ABELES for sugar. So DRJABELES @gmail.com. Simply write to me. Introduce yourself to me, and I will then link you to the company.
Okay. And before we go, just to show that the multifaceted individual over here, I know you said you have offspring who are in the arts, on Broadway and film. Yeah. You actually have a diploma in music, piano. You played piano.
I was trained as a classical pianist. Yes.
Yeah, you're an art enthusiast.
Yeah.
Right.
Yeah, I have a collection. Yes.
Right. Music appreciator. Of
course. Classic. I like art cinema very much. It's really a passion of mine. Yeah. My wife is a classical music singer as well, so she can take part of the blame for having three thespians as children.
Okay, and you're a sports fan?
Yes.
What sports?
Across the board, soccer.
I was going to say soccer is going to be up. You come from across the pond.
Yes, but when I was a young man, I played cricket. I grew up in Rhodesia, which is now called Zimbabwe. Yeah. And my parents were both European Jews. Yeah. And so I have a love of the British sports, soccer and cricket, and rugby.
Rugby, right.
But I've become thoroughly American. I'm American now through and through. I'm proud and happy.
So you like baseball, American football?
My 2 kids, David and Daniel, were wonderful baseball players. In fact, my oldest son went to Emory on a baseball basis.
Very cool.
And they still play softball in Central Park.
Yeah.
while they're doing
Oh,
their
really?
art
Okay.
stuff.
They play with the Broadway League?
Yes, of course they
All
do.
right,
Yeah,
all right, yeah.
My younger son plays with the Atlantic Theatre,
Uh-huh.
and my oldest son
Fabulous.
plays with the shows that he's on. He's been on a lot of
Uh-huh.
different shows, in lead shows. He's
Yeah.
currently in Harry Potter, and he's going to
Oh, very good.
he's going to be Ron
Well, so you
Weasley
get
out
tickets, huh?
in San Francisco.
Yeah.
They're doing a second show
Yes.
in San Francisco. My daughter was 5 years with Phantom of the Opera. She was singing Carlotta.
All right.
The bitchy Italian diva, and I like to say my daughter does that very well.
Thanks, Dad.
She's great. She's a wonderful mother now.
Yeah.
And, my children are producing these beautiful granddaughters for me.
Real quick before we say goodbye for now, I was at the U.S. Open Cricket Championship, and I'm there and I'm watching a game being played, and I forget his name, comes up to me, the head of the U.S. Cricket League Association, and we're talking, and he said, "Are you enjoying the game?" I said, "Yeah." He said, "Do you know what's going on?" I said, "No clue."
Well, I had to learn baseball and football, and I'm an ardent fan of the Niners.
Okay.
Having lived in the Bay Area, and I
Yes.
still have season tickets.
Okay.
So I go
All right.
back there because I go to the West Coast often.
So you're there at least 8 weeks out of the year.
Well, I take it about 6 games out of
Yeah.
the 8 at home.
Okay, that's pretty good.
And then I split my baseball loyalties between the 2 Bay Area teams. That's the Giants and the A's.
Right.
And I have become an ardent fan of the Warriors, and bemoaning their loss lately. But that was all due to injuries. We could have won without those injuries.
You know what? I agree.
think. Yeah.
I agree.
Yeah.
Well, I thank you for coming in. Hopefully,
Thank
we can do
you
this
very much
again
for having
sometime.
me, and
My pleasure.
I'd be happy to come back.
Dr. John Abeles.
Thank you.
Thank you. We're going to take a quick break. We will be back. We still have more morning and afternoon. Is it morning? It's still morning. We still have morning to go. Don't go away. We'll be back shortly, everybody.
Thank you.